Yes, yes, and now I will take here usage of transformer. Why it is manufactured, why it is constructed, what is the use. Number one, main use of transformer is in the distribution, I should say transmission of electric power. This is very useful. Very useful actually. Knowledge is here so that you may get everything. Actually, electricity is not generated in every town. Electricity is generated at large distance from the consumer. I think you get my point. Electricity is generated at large distance from consumer. Wherever you live, in that town, it is not generated. Then how to transmit? Electricity is transmitted through wires. Thus, electricity is transmitted from generation plant to consumer through conducting wire. Every conductor has resistance. Every conductor has a resistance. Now suppose you want to transmit power of, or you are using here at your place a machine which operates at 2 kilowatts. Simply I am telling. Suppose we are using a machine here of power 2 kilowatt which operates at 200 volt. Suppose, then from equation power equal to VI, I here equal to P upon V 2000 upon 200. So we need 10 ampere current. Now this current, suppose we are generating DC. If power plant is 100 kilometer from us, from the consumer category. whose line has resistance of 0.5 ohm per kilometer. So 100 kilometer means 200 kilometer wire. So resistance of line, total resistance of line is equal to 200 into 2.5 means 100 ohm. So power lost in the line I square R. I is 10, 100 square, 100 into 100 means 10 kilowatt, 10,000 watt or 10 kilowatt. It means to operate is 2 kilowatt. The power plant has to send to us. That has to generate 12 kilowatt. But we need here 2 kilowatt. 10 kilowatt loss. So power to be generated by for us is 12 kilowatt. So this much loss for a single consumer is not economical at all. So what to do? Heat loss proportional to I square. So we have to minimize current. Actually, dear student, I want to tell you, if we are producing the electricity here and consuming here, then it is useful to use DC generator. In your vehicles, car, train, bus, scooty, motorcycle, there is generator which generates DC because that is used at same place. But when generation plant is at large distance from consumer, then electricity is transferred through conducting wires. So conducting wire has resistance, so power loss is certainly there. So how to minimize? Actually, thus power produced is I square R. Two factors are there. Either you decrease resistance. When you decrease resistance, so you need thick wires of conductor. Thick wires are costly, become heavy, and so we need strong pillars to support the load, and hence the line installation will be costly here. So what to do? I square is the bigger factor because heat proportional to square. So we reduce current to avoid this line loss. We should decrease current in the line. This can be done. This can be done using transformer. Using transformer. How? At generation plant. At generation plant, we step up the voltage produced by generator. discharge the voltage by a generator to a very high voltage, and we know secondary coil of transformer has lower current than primary. So that power produced is transmitted through wire at low current and high voltage. Now in towns, actually we are using here at 220 volt, and this step transformer may be of 40,000 volt, 20,000 volt, depending on distance. You might have seen different type of lines, transmission line. Some big pillars are there, very high lines, some are lower lines. So because it depends on distance at which you are transferring power. So what the powerhouses in our town are doing, our powerhouses are obtaining voltage at very high volt, or 40,000 or 20,000 volt or 33,000 volt. The powerhouse step down that voltage to 1100 volt only, and then this transmit it to the colonies where we have another transformer which steps 11,000 volt to 220 volt, and that way by using step up transformer and step down transformer we can save great loss of line loss. Secondly, if resistance is there, very potential difference V is equal to IR also. At large distance potential drop will occur. I will show you one example here. So this is one way, one use of transformer, and you can write directly. If you want to explain, give the example like this. But this is the main use of transformer in the transmission of electric power generated. Now, usually we are using some machine, we are getting voltage at 220 or 230 volt. But some machine require high voltage like X-ray machine. X-ray machine require nearly 2000 or 3000 volt. So they use their own step up transformer. And like I told you, the charger, cell charger or any type of charger, nowadays we are everyone having the inverter at home. The battery used, that is called accumulator or lead acid battery, is of 12 volt only. We are getting 220 volt. So first of all we step down. There is a transformer inside that which steps down the voltage to 12 volt and then convert that into DC. Not only this, DC also, because in charging we require direct current. We can't neglect the direct current. It has its own features and more application of DC. So this way, so many you can read from the book. Now I want to tell you one question here, which is from NCERT book, and that question number is here. This is question number 7.25. Question number 7.25 in NCERT. 7.25, yes. They say a town is getting power through step down transformer. I mean, whose voltage here, it is a load resistance, and it needs 800 kilowatt through a transformer A small town with demand over 10 kilowatt of electric power at 220 volt is situated 15 kilometer from the, ये 220 volt है इसके यहाँ पर 220 volt and getting power from a generation plant here which is 1500 kilometer. This is a generator here. Generator. We generate at 440 volt. Yes. 440 volt. And here it gets 220 volt, 4000 volt. Step down transformer, 4000 volt. Here the load. Now this transformer is step down transformer. This is called primary and secondary. This is the primary and secondary. 15 kilometer is the distance. The line wire has resistance 0.5 ohm per kilometer. Once 1 year I gave this question in pre-board exam as such by drawing diagram. And the same year it was asked in board. Very important question because it illustrates, this question illustrates the unity of transformer where we are using it. तो पहले पूछा है what is the line loss? To estimate the power loss, line power loss in form of heat. तो line loss, heat loss, actual power is equal to I square R. So we need first of all resistance of the line. Resistance of line. 15 kilometer and 15. Indicate 15 plus 15 into 0.5 means 30 into 0.5 means 15 ohm. 15 ohm new only resistance. The town is getting power of 800 kilowatt through this transformer. So current in the line क्या होगा? We assume here transformer to be 100% efficient. 800 kilowatt here, so 800 kilowatt here. I mean, so current in line. Power is equal to V into I. Power 800 kilowatt. 800 into 1000. V 4000. And I. Here is the I. This I. So it will be I equal to 200 ampere. So here I equal to, मैं इसको रिव्यू कर देता हूँ. By power equal to V into I, तो पावर है 800 किलोवाट, 800 10 to the power 3 और V है हमारा 4000. It is I. So I will be 200 ampere. So line loss, power lost, line power loss. I should write here line power loss in the form of heat. I square R is 200 square into 15. It is 4 into 10 to the power 4 into 15. 15 4 is 60. 60 into 10 to the power 4 watt. Or it is 600 kilowatt. 600 kilowatt. And required was 800 kilowatt. See, 800 kilowatt power was being given to the town, 600 kilowatt lost. So the second part is asked here, how much power plant must supply? So power supplied by plant. power supplied or power supplied by plant calor or power generated or power generated by plant equal to 800 plus 600 kilowatt means 1400 kilowatt. You understand, kilo means 1000. And then you are asked here, characterize the state of transformer at plant. The plant that was generating at 440 volt. You are asked here the voltage here, because power generated is 1400 kilowatt. So 1400 kilowatt here, power is equal to V into I again, 1400 into 10 to the power 3, V I 200. So V here, this V voltage. Secondary coil होगा ये primary here generation. So Vs here will be this is 7. So 7000 volt. So this step of transformer is 440 volt. 440 dash 7000 volt. Actually here this is a custom right, first primary and then secondary coil. So we can do this thing like this here. Then 7.26 question is there. Can repeat the same question by using transformer at 40,000 volt. 2-22 volt. टाउन पर जो ट्रांसफॉर्मर है अगर वो 40,000 वोल्ट है, that's 220 volt. So how much will be the line loss? Repeat the same question. You can do it yourself, and this way I have almost finished the chapter of AC. I will tell you some more questions so that you get the good information and good practice of question. Thank you.